Good afternoon, everyone. I'm Leah Denley from UNI's Metal Casting Center. Before we get started with today's webinar, I would like to run through a few housekeeping items. I will be muting everyone for the course of the webinar. If you have questions, please feel free to enter them into the chat window and direct them to Hannah. The questions will be answered at the end of the webinar. I will now turn it over to our first speaker, Jeremy.
Thank you, Leah. Appreciate it. And everyone, welcome. We're excited to get together today to share some key insights about additive manufacturing from some of the industry's best players. We're going to show you how the Rize technology is making additive more sustainable and more inclusive. I'm looking forward to a deeper dive into these ideas and showing you why sustainability and inclusivity matter for additive manufacturing and how Rize in particular is helping to move our industry forward. Excuse me. I also want to preface these comments with a personal note about the Rize team and the Rize technology. Now, I have been so impressed with the Rize team. Eugene, the founder, has put a great deal of effort into bringing people into the company who are not only brilliant minds, but genuinely good people. Everyone from the CEO on through to the guys in tech support have this quiet humility that we so much appreciate. And the Rize technology is kind of the same way. It has a quiet humility about it, seeming like just another desktop filament machine, but there are huge differences, and that's what we're going to explore today. And as we like to say here in Iowa, the proof is in the pudding. So in the 30 days on either side of this webinar, we've installed machines at the corporate centers of excellence for two major manufacturers. Now, I can't share who, but I can share how inclusive the technology is. Both of these are global players, but in very different arenas, one heavy machinery and one aerospace. So this is an exciting time for Rize and an exciting time for the AM industry. So I want to take a minute now to get to know who's on the other side of the webinar. Andy Berlin is going to join us here in a moment, and Andy is the product manager for the Rize One. Andy has been part of the additive manufacturing industry for over 16 years. He helped bring the Rize One 3D printer to market, and he will play an instrumental role in scaling Rize's Augmented Polymer Deposition technology across enterprises by leveraging its unique sustainability, part strength, and ease of use advantages. Now, previously, Andy led teams building firmware in both the semiconductor and wearable industries. He was also a key member of Z Corp's engineering team, where he wrote the firmware for multiple products during the company's period of rapid growth. And then there's Jeremy Voss, that's me. I'm the sales director for RP America. My background is as a successful entrepreneur. Since 1999, I've been building strong companies focused on joining technology and uncommonly good customer experiences. I sold my last equity stake in 2014 and joined a little tech startup called RP America in this crazy business called 3D printing or additive manufacturing. We've grown dramatically since then, and we are looking forward to an incredible 2018. RP Support was founded by Dan Terpstra in 2011. Dan's the one in the front on the left there with the glass. He's the only guy with glass. No. He's the guy with glasses. Our company heritage is in on-site support for stereolithography machines and stereolithography materials, the original 3D printing technology. Now, since then, the support side of the business has grown steadily. In 2016, we founded RP Sales to meet the need we saw for 3D printer sales. We recently rebranded both organizations under one umbrella, RP America. Our first equipment line was Union Tech, and since then we've added Rize, Desktop Metal, and Somos Materials. In this picture, you can see our office team. Now, the folks that you don't see here are the real heroes in the company, our field engineers, our road warriors. We cover the entire US with our field service team. RP America is actually located in a barn in the middle of a cornfield in Iowa, and that's no joke. I'm sitting in the barn right now. The barn is a beautiful, brand new 7,000 square foot facility, which contains a state-of-the-art additive manufacturing lab, offices and workspace, and also space to work on tractors. Again, no joke. We use that red barn logo you see there whenever we talk about our core values, and those are values that we hold close and that are the basis for everything we do: family, hard work, integrity, and fun. And just to give you an idea of how we roll, the top left photo shows Sean from Union Tech. While he was here from China, he got the opportunity to drive both the oldest and newest tractors on the farm. You see him above on a 1950s John Deere. The bottom picture was taken during the peak of harvest season with equipment staged and ready for harvest. There's also a beautiful pond just down the hill from the office where our staff regularly go fishing. As you can see, there are some beautiful fish in that pond. It's not all corn and pigs, though. As I sit here in my office today, there's a group of people on the other side of the wall. They're from a global technology company, and they flew in specifically to use our lab to learn about the technologies that we represent. We regularly host high-profile visitors from around the world, and that part really is fun. RP America and Rize met at the 2017 AMUG conference. Now, after the show, Eugene talked us through the process and showed us some sample parts. We got to snap off the supports, and we could instantly see how this could be a game changer in the industry. We've been talking about Rize with our customers ever since. Here you can see a photo of our Midwest sales manager, Jeremy Owen, at our expo in Minneapolis this fall. He was talking to a group about the Rize printer. We've been finding that our customers love how easy it is to remove supports, but it goes far beyond that. The material properties, the safety and sustainability of the process, the unique ways people are finding to use the marking ink, they all mean that this machine can do more and go more places than any machine we've seen. So let's bring in Andy from Rize and walk us through how they're working to make sure that AM is sustainable and inclusive, making it achievable at scale. Andy, let's talk about some of the ways manufacturers in all industries are already using Rize and how it can be translated to the shop, factory floor, and even into the field.
Well, thanks for that intro, Jeremy. You know, Rize is also proud to be part of the RP America family. I'll dive right in, and I want to start with this statement. Adoption of additive manufacturing will be driven by systems that are sustainable and inclusive, because these are the principles on which we built our technology. But first, what does additive at scale mean? When we talk about scaling, we're talking about wider adoption by enabling new use cases for additive manufacturing. So progressive companies are already providing it for design engineers, making functional prototypes for iterative design. And as material properties have improved, additive is taking root with manufacturing support, making custom end-use parts. More recently, companies are starting to make parts that actually go into the product, where the benefits of additive tip the scales away from traditional manufacturing techniques, such as in situations with lower volumes or unique geometries. And ultimately, a lot of companies want to see additive used for replacement parts, to reduce the money tied up in spares inventory and to increase the speed at which a broken machine can be brought online again. So these are some of the ways additive manufacturing can be leveraged across a business. The common theme in these diverse use cases is the notion of pushing the process closer to the point of consumption. So, of course, additive is in the lab, where a lot of companies use it now, but it also belongs in the office next to the design engineer. It belongs in the factory next to the manufacturing engineer and next to the production line. And it belongs in the field next to the end user.
Hey, Andy, what you were saying there just reminded me of a story from one of our customers that needed a really strong tool, and it's kind of like the factory floor picture really sparked that for me. So they needed a strong handheld tool that they used in their assembly process, and they were machining them out of aluminum. They were very strong, but they tended to get lost or dropped, and they were expensive being machined out of aluminum. And so what they were able to do is they were actually able to print that same tool on the Rize machine for a fraction of the cost. And they were actually able to do that and have a handheld tool that their assembly folks could use, that could be used over and over and over again. And I think that the end cost on the tool wound up being like $4. And the cool thing about that was as they iterated the tool, they could actually change it and give everybody a new tool for 12 or 15 bucks a pop. It's just a really good example of taking additive right to the factory floor.
Yeah, that's a great example, a great end use case. So before I talk about sustainability and inclusiveness, I want to introduce our technology because it'll help when we talk about those principles to talk about them in the context of a real world solution. So Rize has patented a process we call Augmented Polymer Deposition. This is a hybrid technology, polymer deposition plus piezo printing under the same cover. So polymer deposition is an FDM process, extruding a thermoplastic layer by layer to build a part. Piezo printing is jetting fluids onto the polymer to change the properties of the polymer on a VOXEL level. And this gives us two really unique advantages. Number one is near zero post-processing. So we use one of the piezo print head channels to jet a release agent between support structures and part. So when the part is finished building, you can simply peel off the supports from the part by hand without tools, and you end up with a great surface finish. And it takes very little time and doesn't require any additional equipment. So that's what we call near zero post-processing. The other great advantage is labeling. So we use another channel in the piezo print head to jet a marking ink onto the polymer. And this adds a whole new dimension of functionality to parts. You can put part numbers, serial numbers, tracing information, usage information. I'll go into this a little bit deeper later, but labeling is a great advantage. So when we developed this technology, we also wanted to develop a polymer to complement it, and we focused on two features. One was isotropic strength. So isotropic strength means the layer-to-layer bond, the z-axis strength, is as strong as in the x and y axis. And this has been verified by third-party testing. We get over 70 megapascals flexural strength in all three axes. This is isotropic strength. And the value here, the great thing is you don't have to worry about orienting your part for strength in the build or designing your part to compensate for weak z-axis strength. The other feature we wanted to focus on was safety. So when we developed our polymer, we came up with something that we make with medical grade components that don't leach, contaminate anything they come into contact with, and they don't emit VOCs during the print process. So here's a more graphical representation of how it works. On the left, you see an extruder, which extrudes the thermoplastic, and on the right, the print head, which jets different fluids. So first, the extruder extrudes a layer of support material. Then the inkjet, we jet a release agent on top of the support. Then we extrude part on top of the release agent, and this is what enables the great easily removed supports. Then we can jet into the part different inks to change the properties of the polymer, and we've done that to add marking ink, to add labeling and graphics. So when we built this machine, we made something that's industrial class. Industrial meaning it's durable, it's highly automated, it has a locking cover, heated chamber, hot swappable filament, build plate detection, network and USB connectivity, a touch screen for simple operation, and of course, UL and CE certification. So we also built the machine to be office compatible. It fits on a desk. It's small enough to be moved easily by a couple people. It's quiet operation, so it doesn't disturb you. All you have to do is plug it in. There's no additional facility requirements, which is key. There's no extra equipment. You don't need hoods or vents or plumbing or waste management. It's just sits on the desk, and what you see is all you need. All right, so that was a quick intro to the technology. Now I want to return to these notions of sustainability and inclusiveness. So what does sustainable mean? Parts don't break, process doesn't break, and people are safe. I'll describe those in a little more detail. So parts don't break. We already talked about the advantages of isotropic strength and how valuable that is. Low moisture absorption. This means the properties of the part won't change over time. They'll remain consistent. Chemical resistance to alcohols, ketones, and acids. This means the part can be used in applications where it may come into contact with these common substances. And high heat deflection temperature means you can use the part in high heat environments without it deforming. These are the properties of the part that make, these are the properties that make these parts really durable.
And Andy, that impeller on the top there reminded me of another customer that we were working with. Just and the strength of these parts, we were able to print a part that needed to be tested at 3,500 RPM, and that's pretty fast. It was a challenge for sure for some different materials, and we were able to do that very successfully with Rize parts. At 3,500 RPM was no problem at all. So they are exceptionally strong.
Yep, they're very durable. So I want to talk about that strength a little bit more too, and compare it to some other additive manufacturing technologies. So here's a graph showing the strength of an SLS part versus the orientation in the build. And the key takeaway here is, depending on the part orientation, the strength could be as much as 20% different. So this is not an isotropic technology. Here's another comparison. This is another high performance polymer versus ours. The blue graph represents ABS+, the red graph represents our polymer. On the left, you see the molded strength. Those bars represent sort of the as good as it could get strength of the polymer. The middle graph represents the strength kind of along the axis of extrusion. You can see ABS+ still holds up pretty well, but the key thing here is the graph on the right. You see that this represents the layer-to-layer bond, the Z strength, and ABS+ is only 60% of the strength in the ZX axis versus the other axis, whereas our polymer is almost identical, and this is what we mean by isotropic. So that's durable parts. Another element of sustainability is the process. The process doesn't break. This means your process doesn't break. That is, additive manufacturing shouldn't add friction to your already existing workflow. On the left, you see someone taking the supports off a Rize part quickly by hand. And on the right, you see someone using soluble supports. Notice that it adds a lot of time to the process. There's a tank, cleaning fluid, an operator wearing safety gear who has been trained to use this equipment. So it adds time, it adds additional equipment. You need a lab environment, and you need a trained operator. So this is what adds friction to your process. Here's a report by Todd Grimm, a well-known industry analyst. And this is his take on post-processing. He calls it a non-value added operation that increases overhead, complicates the workflow, adds expense, extends delivery time, and in the lab, this is undesirable. And in our use cases, in the office, this is just not viable. So we talked about durable parts. We talked about reducing friction in the process. Now let's talk about why safety is important to sustainability. For additive manufacturing to be sustainable, you need a system that's not harmful to the user, so it can be used by anyone. Here's a study by IIT showing some typical FDM thermoplastics, which emit VOCs. Wherever you have FDM machines extruding typical thermoplastics, you have VOCs, volatile organic compounds, which means you need venting. If you've ever set up a print farm, you know what I mean. The Rize thermoplastic is not on this list because it emits 0 VOCs. Here's another existing technology, water-soluble supports. It sounds clean, but it requires high alkaline cleaning agents. It requires a heated tank, a trained operator wearing safety gear, and careful disposal of the used solutions. So this supposedly safe technology requires extra equipment, gear, a lab setting, and waste management. And these are the drawbacks of the technology that prevent it from being used by just anybody.
Andy, that just reminded me, I think it was a week ago, yesterday or today, I was on a customer site, and they had, we're replacing a fleet of FDM machines. and they had this massive setup there for dealing with the waste. Huge wash tanks, and then they actually, because they couldn't complete the plumbing where they were at, they actually had to take everything in and out with fork trucks to do the solvents and all that stuff. It was an incredibly complex and expensive process, as opposed to just snap and taking those supports off. It makes a big difference for a lot of customers.
Yeah, that's right. I mean, it adds, you need lab space, you need waste management, and you need trained people to do this stuff. So it does add a lot of friction to the process. So to return to our material for a moment, our Rize polymer is made with medical grade components that are skin and food contact safe. They don't leach or contaminate whatever they come into contact with. The components are FDA approved, it's recyclable, they don't emit VOCs, and they don't require chemical post-processing. These are the elements of safety that Rize brings to the table. So that was sustainability, durable parts, frictionless process, safety. Now, inclusiveness is very direct. Parts are suitable for more applications, and the process is accessible to more people. Parts suitable for more applications. What I mean by that is functional parts must be strong, durable, and accurate, which means they can be used for jigs, fixtures, tooling, and work holding, as illustrated in these sample parts. Parts can be used for casting. Our polymer has a very low surface tension, which makes it ideal for certain casting applications, such as making silicone molds, such as in this customer part. And labeling adds a whole new dimension of functionality to the parts. So you can add usage instructions, such as shown on this fixture, safety information. You can add identification and tracing information, such as part numbers, revision numbers, serial numbers of every part that's printed, date and timestamps of when the part was created or even when the part was printed, the lot number of material that printed the part, the serial number of the machine that it was printed on. Labeling provides total traceability.
And I would add too, Andy, that it's also completely unique to our industry.
Yeah. So that was inclusiveness, meaning the parts are for a wide variety of applications. And now about the process being accessible to everyone. A system that doesn't have additional facility requirements, doesn't require additional hardware for post-processing, doesn't require specially trained operators, doesn't require protective gear, and there's no safety concerns. These are the elements of a system that can be deployed anywhere and used by anyone. So to summarize, our key belief is that the adoption of additive manufacturing will be driven by systems that are sustainable and inclusive. And sustainable means durable parts, frictionless process, and safe for people. And inclusive means parts that are suitable for more applications and a process that can be deployed anywhere, accessible to more people. So that wraps up my talk. I want to thank everybody for listening, and I'm going to hand it back to you, Jeremy.
Awesome. Thank you, Andy. I appreciate it very, very much. Some great insights, and it's always neat to talk to guys like you and hear from guys like you that have been in the business and in the industry and been a part of this from the very, very beginning. We'd like to remind you, if you want to shoot some more questions over, we're just about wrapping up here, but we've got a couple of them that we'll answer. Andy and I will probably tag team them. But wanted to also remind you that you can reach out to me anytime. Here's my contact information. It's actually the Jeremys at RP America that handle the sales. So me and Jeremy Owen. But if you reach out to me, we'll get back to you. We'll also be doing a follow up with each one of you that was on the call today. Also, you'll be getting a copy of the presentation so that so you'll be able to utilize that information however you want to. So again, go ahead. We've got a few minutes here, but we want to be respectful of everyone's time. But we got a couple minutes to field some questions. One that we came across here. Oh, this is a good one. Andy, do you want to talk about who are some of your customers? I can talk about that too. Do you want to pull that one, Andy?
Well, I can't name everybody, of course, but we can name some. Some of our big customers include Merck in the pharmaceutical industry, NASA, the U.S. Army, Thermofab, just to name a few.
Yep. I really would. There's a few on that list that I would like to be able to name that we can't, but that's okay. Here's one that I can definitely handle. What's the cost of the machine? So we're looking at about $35K all in. That includes a table, starter kit, warranty, all of that stuff all bundled in is right around 35. If we need to get more detail than that, we want to talk about a fleet of machines in multiple locations. Those are the kinds of specifics that I can definitely get with you on and make sure that we've got it. Andy, you want to take this one? How fast do you print? How fast is the printing?
Sure. So it's a little hard to quantify. We are faster in some geometries than FDM. So if you're comparing side by side with other FDM technologies, but what's really important to think about is how long it takes to get to a functional part. So from the time you start printing to the time you can actually use your part, which includes the post-processing. When you take post-processing into account, we are like 50% faster because of the near zero post-processing capabilities of the Rize machine. So it's a tough metric to really compare, but when you look at the big picture, we're a fair amount faster.
Yeah, I think that's fair to say, Andy, that you've got to really take into account that whole process, and honestly, it's the post processing with a lot of these other technologies where it's really labor intensive. You know, you can just let the machine run overnight. That's not where you really get that where it really bites is when you've got somebody that has to spend that time doing that post processing. So that's good. Here's another one. What is the material cost? So a spool is about $150 for a spool of material. And Andy, I'm having a brain cramp. How much material is on a spool? Darn it! Sorry.
Yeah, let me remember that.
Between the two of us, we ought to know this. I do apologize.
It's 50 cubic inches of material.
That's right. So 50 cubic inches, $150, and then the ink and the release cartridges are good for multiple spools, and they're $215 each. So, and then also let's do this one. Andy, can you tell us about how long the printer has been around? I know we kind of touched on that, but we can probably kind of wrap that up a little bit more clearly.
Sure. Well, we were in development. Rize is a startup, and we started developing this printer a few years ago. We first brought it to the market last July, so it's been a little less than a year on the market. Gotcha.
Yep. All right. Very good. Well, thanks everybody for your attendance. Thanks for listening in. Thanks for your interest in Rize, and we'll look forward to hopefully having a conversation with each one of you as we go through. Thanks also for the good questions. Everybody, hope you have a fantastic day, and we'll look forward to talking with you soon.